All right, hello students. I wanted to take an opportunity just to go over again the concepts of what we were talking about, excuse me, in class yesterday because it seemed like we needed to review some of the things, and so I just want to solidify some of the concepts. And so the first thing that we want to make sure is clear is that y equals mx plus b. This is the slope-intercept form of the equation of a line. And so one of the big questions that came up yesterday was, do x and y need to be in the equation of the line? And the answer is yes. And the reason is because we are on the x, y coordinate plane, and a line shows the relationship between x and y. So a line is a function, you plug in an x, you get out a y, the line passes the vertical line test. But in order for it to be an equation of a line in the plane, yes, it does need to have x and it does need to have y. Okay, so the next step then is, well, what does the x represent? Well, the x represents all the inputs and the y represents all the outputs. So the x and y that you see in the equation are the exact x and y that you see on the coordinate plane. What about the other letters? M is the slope, and it is rise over run. So you just need to see how, from point to point on the line, how far do you go up, how far do you go over. What's B? B is the y-intercept. And so this is where the line crosses the y-axis. So let's go ahead and graph a line. And so let's say that this line starts here and it goes like this. Okay, so there is my first line. And now I'm wondering, okay, what's the equation of this line? So the equation of this line is going to be y equals mx plus b. Y and x have to be there because it's an equation of a line. The easy part is b. Where does this cross the y-axis? Well, this line is crossing right here at 4. So my b is going to be 4. I know the y and the x have to be there. I know the equal sign have to be there. They're always going to be there when we're writing the equation of a line. But now we're looking at the slope. All right, well, let's look and see. In this case, when I go from this point, and this is the easiest point to see on a graph like this where I don't have graph paper, so you guys have an advantage because you've got the graph paper here. But when I'm going from this point to this point, and here this is at 8 on the x-axis, but I'm looking for the rise over the run. But in this case, when I go from left to right, when I go from here to here, I'm actually not rising, I'm falling. I'm doing a fall over a run. And how do we indicate down symbolically in math? We do it with a negative sign. So in this case, I go down 4 and I go over 8. So I go down 4, down indicated by the negative sign, and over 8. Okay? This can be simplified, and so we definitely do want to reduce it. And so this is going to be negative 1/2, because 4 is half of 8. So this is going to be y equals negative 1/2 x plus 4. Okay? Now, in this particular example that we were working on yesterday, we didn't have one line, we had 2 lines. And we were looking for 2 lines that intersect. So I'm going to, again, this is much easier to do on your paper because you have a grid. This whiteboard does not have a grid. But I am going to do this second line like this. I'm going to add some tick marks here so that I can see where this is crossing, and then we're going to do the whole thing over again. The form of the line, y equals mx plus b. I know those parts are going to have to be there because that's just part of the equation of the line. X, if it's a line, x and y got to be there. Otherwise, it's not the equation of the line. Now, here, actually my b is -2. So I'm going to change the sign here to -2 because that's where it's crossing. Now again, we want to find the slope. Here, these lines are crossing at 4, 2. And so I'm going to look and see, okay, how far do I rise from -2 up to 2? I rise 4. So here my slope, m is going to be equal to 4. And then how far over do I go? From 0 to 4, 4. So in this case, my slope simplifies to 1. And so I can write 1 here to stay organized, or because if there's no coefficient, 1 is implied, I can also just write y equals x minus 2. Either of those is fine. So now we can see we've got two lines. We figured out their equations from their y-intercepts and from their slopes. And what looks like here is that we have the two lines intersecting at 4, 2. But now we want to check and see, are we correct? Have we correctly gone from the graphs to the equations of the line? The way that we check is that we plug in a point and see if we end up with a statement that is true. So let's go ahead. So down here is where we're going to go ahead and check our work. And so we're starting with the blue line. And so we've got y equals -1/2 x plus 4. What x and y are we going to plug in? 4 and 2. So is 2 equal to -1/2 of 4 plus 4? All right, is 2 equal to, so -1/2 of 4 is -2 plus 4. Is 2 equal to 2? Yes, it is. So we've plugged in a point and we've checked to see that we've gotten a true statement. We've gotten that 2 is equal to 2. Awesome. All right, let's go ahead and check it with our green line. So here our equation for our green line, y is equal to x minus 2. We're going to check this guy in the same way. We're going to plug in this point. Is 2 equal to 4 minus 2? This equation is even easier. It's already becoming apparent. But yes, 2 is equal to 2, and check. So we've written the equations of the lines, and then we plugged in this point because it's on both of these lines to check and see if our equations are correct. Yes, they are correct. Okay, so I'm going to do another video that then is going to show the next step of what we are doing with these lines, but hopefully this is an example that will help you to check and make sure that your equations of your lines are correct.